Okay, let's tackle spring force now, and this file is the file that we used for our gravity example. So just bring that up, open that one up, and then we'll change it. The way that we're going to set it up is we're going to set it up a spring between movers, and that for us is just going to be easier. I'd really encourage you to watch Daniel Shiffman's his video on spring force because it's really good. But it's not really that hard because we have force. We've got our movers that we can apply a force to our mover here, and so it's really not that hard. But like I said, the slight difference between this and what Daniel Shiffman does is we are going to set it up as this mover to other mover, and he makes a separate class that is a spring. But this is the way that we're going to do that. So let's do definition spring 2, and we're going to pass in self like we always do, and then we're going to pass in other mover. And this really isn't that much different from our gravity. But okay, so we need two arbitrary constants. We're going to do rest length, and let's just have it for 10 for now. And then also k, we're going to have it as 0.1, and k is the strength of spring. Okay, so now let's get the direction of the vector from this mover to other mover, and so we're going to call that direction vector, and it's going to be rs vector create 2 point from point. So the 2 point is going to be other mover and position, and then from point is going to be self dot position. The current length is just the direction vector unit, or the direction vector length. So current length is rs dot vector length, and direction vector, and our stretch, our x value, is just the current length subtract rest length. So we have rest length and current length. So stretch, and we're doing this just like Daniel Shiffman did, where x, doesn't say much, but stretch gives us kind of more information about what the variable is. So current length subtract rest length, and so now that we have that information, we want direction and magnitude. The direction is just the direction vector unitized, so we're just going to call this direction equals rs dot vector unitize, and we're going to pass in direction vector. And then the magnitude is this right here, the force minus k times x. So we have minus k times stretch. And okay, so now that we have these two, we can put those together to get force of the spring. So rs equals vector scale, and we have direction and magnitude. So now we just need to apply it. Self dot apply force and force of the spring. So we have that. I'm gonna knock this down to 2 just to begin with. Line 71, unexpected token stretch. I need to put the parens on there. Okay, so now let's go in and we're just going to substitute out our attract to, and let's rename this attract to by gravity, or gravity attract to. So we just need to put spring to. Okay, you can see I did something wrong in here. Let's find out what it was. I think I put these in the wrong positions. So vector create self position, and then other mover dot position. Okay, so now instead of acting by gravity, these are acting according to the definition of a spring. So I'm gonna come back to this in a second, so I'll just quit here.